Hey everybody, happy Monday. It is Mr. Marker with you once again. Today is closure day. So what that means is we are studying and getting ready to take that Chapter 5 test, which is scheduled for Thursday this week, or maybe a little earlier if you're checking out a couple days early for spring break. If that's the case, make sure you please reach out to your grading teacher. Let us know so we can get that test shared with you ahead of time. That way you can take it before you leave for spring break. Otherwise, for everybody else, the test is on Thursday this week. We have no quiz Wednesday because, again, we're taking that test on Thursday. And since it's the last week before spring break, let's make sure that we finish strong this week. Get your work done ahead of time. If you're missing any stuff before we go into spring break, whether it's still tests, quizzes, or homework, hopefully we got that stuff done before the end of the quarter last week anyways. But again, this is kind of a nice breaking point in the semester, so that way it gives you a clean slate when you come back from break. So let's get caught up if we are a little behind. Otherwise, let's get to it. So the whole point of today's lesson is to get us ready for that Chapter 5 test on Thursday. What we're going to talk about today is first the homework from last Thursday, the 533 stuff, what's going to be on the test, what we can expect to see on that. Make sure we got our toolkit check filled out, and then I'm going to walk through a couple problems that we can expect similar types of problems to be on the test for Thursday. Awesome. So first, 523 homework answers. If you want to check these out, pause the video so you can see them in a little more detail. Otherwise, we're going to keep moving. So what we can expect on that Chapter 5 test for this upcoming Thursday are the following things. So first and foremost is all the stuff we've talked about with sequences is fair game. So how to identify arithmetic, geometric sequences, or if it's not a sequence whatsoever. And you should be able to identify those by a graph, equation, a sequence, or even a table, just like we saw in the quiz from last week. So all of that is fair game. We should also know how to write an equation when given a sequence. So I'm going to change that because there's a little typo. We want to write an equation when given a sequence. So again, if we had a whole list of numbers, we want to be able to write that explicit and recursive formula from that list of numbers or sequence of numbers if we are given that. Also, we want to be able to kind of do that opposite. If we're given a sequence, we want to be able to write if we're given the equation, we should be able to plug in term numbers and then write out the actual sequence of numbers that is generated by that equation. Lastly, or a couple more things here, we should be able to find the nth term when given an equation. So again, if we know, let's say t of n is 4n plus 3, if we know that t of n is equal to something, we want to figure out what's the term number that's going to make that true, if there is one. So, and then a couple other review type topics on the test, these last three. So first, we should always, and hopefully know this from Chapter 2, but how to find the equation of a line in a variety of ways, whether it's between 2 points, given 1 point, and we need to find the slope and the intercept. And then, again, a big one, how to solve equations in function notation. And then last but not least, we're going to have a couple of questions on our exponent rules and how to simplify those expressions using exponent rules. So again, that's what we can expect to see on the test. Hopefully today's video is a good way to get us ready for that, because we're going to walk through some of those problems in just a second here. So before we actually jump into working through some problems, let's do a quick toolkit check. So again, you've got that single sheet of gold paper. That's our toolkit. It's our cheat sheet for this test. It's got everything that we need to know in order to be successful on this upcoming test in regards to our Chapter 5 stuff. Hopefully we have our previous ones still and have not thrown those away, because we could use those as well for this test. So again, I'm just going to kind of scroll slowly on this, pause the video at different spots if you need to fill out certain parts of it, but hopefully we have all this stuff filled out from class anyways. But I'm just going to kind of scroll through, make sure this is all filled out. If you need a little more time with it, pause it, and then we're going to move on to some problems. Our gold homework packets, we are hopefully opened up to our Chapter 5 closure assignment. So I'm going to walk us through a couple problems here in this section to kind of, again, get us ready for what we might see on our test. And we're going to start with 124. So we want to determine if the following sequences are arithmetic, geometric, or neither. So the best way to do this is to just kind of look between two terms, see what the difference is. If it's consistent, then we have arithmetic. If it's not consistent, then it's not arithmetic. But if we can kind of notice some other patterns going on there, whether it might be in multiples as we go from left to right, then we might have geometric. Or if there's really no pattern whatsoever, then obviously it's neither. So let's kind of look at A and see what we come up with. So what's the difference between -7 and 3? To get from 7 or -7 and -3, we're adding 4. If we do the same, or look between -3 and 1, again we have to add 4 to get from -3 to 1. We have to add 4 to get from 1 to 5. And then from 5 to 9, again we got to add 4. So this one is arithmetic. Pretty straightforward. Perfect. So let's do part B as well. So -64, we're going to -16. Okay, and then from -16, we're going to -4, -4 to -1. So from -4 to -1, we're adding 3. From -16 to -4, we're adding 12. So just between those two, obviously not arithmetic because we're not adding the consistent amount each time. So let's get rid of that, not arithmetic. But if we look at all these terms, they are multiples of 4. So if we take -64 and then we divide that by 4, we would be able to get to -16. So if we divide by 4, we get to -16. -16 divided by 4 gets us to -4. -4 divided by 4 gets to -1. If we kept this pattern going, then we would get like -1/4, -1/16, and so on and so forth as we go to the right. So go between every single term we are dividing by 4. So this one is going to be geometric. Again, geometric, and we're adding, or not adding, but multiplying or dividing by the same term every single amount. And we can think of multiplication, or if we're thinking about dividing as multiplication, it's like multiplying by a fraction. So in this case, it'd be like multiplying each term by a fourth instead. Awesome. So we go down to part C. We go from 1 to 0, 0 to 1, 1 to 4, 4 to 9. So if we look at this one, from 0 to 1, or 1 to 0, we're going -1. Here we're adding 1. Here we're adding 3. So obviously not arithmetic, because we're not adding the same thing to every single term. Next, if we want to multiply 1 to get to 0, multiply by 0. We can't multiply 0 to get to 1, because 0 multiplied by anything is always 0. So that tells us that that's not going to be geometric either, because we can't multiply by the same thing. So this one is neither. And then last but not least, let's look at the difference for part D. We go from 0 to 2, 2 to 4. 0 plus 2 gets us to 2. 2 plus 2 is 4. So again, our pattern here is +2, so this is going to be arithmetic. And I'm just going to write A. That's a long word to write. So next, we're going to do 125 as well. We want to find the equation of each sequence given this table below. So let's take a look at A together, and then we'll jump in and do B as well. So let's first find what type of sequence we actually have here. So as we go from 4 to 1, we are subtracting 3. If we go from 1 to -2, we are subtracting 3. If we continue this pattern, I think we're going to be subtracting 3 again, which would be -5. So if we're consistently subtracting a number, this tells me that this is going to be an arithmetic sequence. So if this is arithmetic, hopefully that we have our toolkit filled out from just a couple seconds ago, but the explicit equation for a arithmetic sequence is T of n is equal to our difference times our term number n plus the initial value of that sequence at n is equal to 0, which we either called a sub 0 or t of 0. One of the two. They both mean the same thing. So in this case, we just got to plug in what we know. Again, we know we're taking away 3 every time, so that's our difference. So we can say that t of n is equal to -3 times n. Now we just got to find our value when n is equal to 0. So we got to go, we have n is equal to 1, so we just got to go up one spot, up one spot. So for taking away 3, when we go down, we got to add 3 to get our first value. So this should be +7. So our equation is t of n is equal to -3n plus 7. Awesome, let's do part B. So part B, let's take a look at the difference between our terms as we go from 6 to 7.2. This is, we're adding 1.2. If we do the same thing to get from 7.2 to 8.64, we've got, what is that, 1.44. So obviously not arithmetic because we're not adding the same thing. every single time. But if we check this for geometric, how we can check it for geometric is if we take any term and divide it by the previous term, we would get the multiplier or the rate between those two terms. So if we check our rate for this one, if we do like 8.64 divided by 7.2, that tells us that our rate would be 1.2 between these two terms. So we're multiplying by 1.2 right here to get from 7.2 to 8.64. Let's check it for 6 to 7.2 to see what we get here. If we have the same rate, then we know we have a geometric series. So if we do 7.2 divided by 6, we do in fact get 1.2. So that tells me that our rate is 1.2. So when we think about an arithmetic sequence, or not arithmetic, geometric sequence, we know that the general form for that from our toolkit is T of n is equal to G sub 0 or G naught, or again, that's the initial value of our sequence when n is equal to 0. It's G sub 0 times our rate raised to the n power. So we already know r, so we just got to find that initial value for our sequence. And we can do that by taking 6 and then instead of multiplying by 1.2, divide by 1.2. And when we do 6 divided by 1.2, we get 5. So that is our starting value, which is equal to that G sub 0 in our Gorn equation. So if we want to plug both of those values in, we get our final answer to be T of n is equal to 5 times 1.2 raised to the n. Awesome. So I can guarantee you that there's going to be a question like this on the test, so make sure that we feel pretty comfortable doing this stuff on our own. If not, please make sure you reach out to your grading teacher at some point this week and get some help on that before you take the test on Thursday. Awesome. So let's turn the page. We're going to go to 28 next. Again, do a little bit of review with our exponent rules. There we go. Had to catch my thoughts for a second. Let's do some exponent rules and simplify these expressions. So let's start with A. With A, we've got 3x all squared. So again, the quantity of negative 3x all squared. So whenever we see something inside of parentheses and it's raised to an exponent, everything on the inside is raised to that exponent. So that means we have to square everything on the inside here. So in this case, we would basically, if we expand this out, so when we square something, it's something times itself. Just as a little review, it's negative 3x times negative 3x. So if we multiply those two things together, we get 9x squared, which is in fact our answer. So the next problem, part B, is almost exactly the same, except for now we've got a positive 3 on the inside, and our negative is now in our exponent. The negative is now in the exponent. So if we think back to our exponent rules way back in chapter 3, whenever we see something raised to a negative power, so in this case it's like x to the negative 2, that always means that we flip it to make that exponent positive. So we put that on the bottom part of our fraction. So x to the negative 2 really means 1 over x squared. So first thing I want to do with this one is I want to rewrite it. I want to rewrite it and make it look like our positive exponent version right there, which would be 1 over the quantity of 3x all squared. So if we evaluate this now, again, everything on the inside of our parentheses has to get squared, so our final answer is 1 over 9x squared. Perfect. Awesome. So again, we know, let's do part C, and we know that 3x quantity squared, which is the exact same thing that we've got right there that I just highlighted, we know that that's 9x squared from the denominator of the previous problem. So we know that that top part, when we square this, because we have to square it first for order of operations, is going to be 9x squared. So we know that that numerator is going to turn to 2 times 9x squared, all divided by 3x to the third. Let's simplify our numerator first. So if we simplify that, then we get 18x squared all over 3x cubed. And now we finally have something that we can simplify now that we got all of our stuff simplified on the numerator first. So let's see here. 18 divided by 3 is going to get us 6. And then we have to do our exponent rules here with x squared and x to the third. So if we have x squared divided by x to the third, we want to take the top exponent and subtract the bottom exponent from it. So when we do that, we get x to the negative 1, which, as we know, goes to the bottom. So our final answer is going to be 6 over x. 6 divided by x for part C. All right, I'm going to let you do D on your own, but if we do this one correctly, we should get our answer to be 162 times x to the fourth. I would recommend, again, knowing that we have a negative exponent on the bottom, it's kind of the opposite of our rule here. So if we have 1 over x squared, or let's fix that, 1 over x to the negative 2, kind of like what we have here, x to the negative 2, that means the same thing as x squared. So you got to rearrange this first before we start simplifying, but I'll let you work that one on your own. But this is a little hint for us. So move this up to the top first and then simplify from there. Awesome. We're going to do a couple more. So if we go to the next page, take a look at 5(130). We want to write the explicit equation for each recursively defined sequence below. So right now, again, we have the recursive sequence, the one that tells us the next term in our sequence, given the initial one. So we want to find our explicit equation. So again, this one's A, so I'm assuming this one's going to be arithmetic. And if we look at our toolkit for the recursive equation for a arithmetic sequence, that one looks like t of n plus 1 equals t of n, put our parentheses, and then plus our difference, which is exactly the same form that we've got right here. So again, we have our function a of n right here, minus 7. So that tells me that minus 7 is going to be our difference. So d equals minus 7. And again, if we think about the explicit equation for an arithmetic sequence, that's t of n equals d times n plus a sub 0. So we've got n taken care of. Now we just got to find our a sub 0. So we know a sub 1, or the first term in the sequence, is 17. If our difference is negative 7, again, if we think about it how we did in our table, that top row is 17. We'd have to go up once. We have to do the opposite of our difference to get that. So we know that a sub 0, that very first term in the sequence, is 17. We got to add 7 to it to get 24. So our equation for this is going to be t of n equals minus 7 times n plus 24. Awesome. Now we're going to do the exact same thing for B, but in this case we've got geometric. And I know it's geometric because our recursive equation is 5 times t of n. So like it says in our toolkit, that 5 is our rate, or that multiplier. So we know r is 5. Our general equation of a explicit geometric sequence is t of n is equal to g sub 0 times r to the n. So we've got r, we got to find g sub 0, the initial term of our sequence at n is equal to 0. So we know t of 1 is 3. So again, if our rate is 5, so again, every time we add a new term, we're multiplying by 5 to the n power. So we got to figure out what that first term is. So we're basically going backwards. So whatever we multiplied by 5 from our t of 0, we got to 3. So basically we have to do the opposite. So we take t of 1, and we got to divide that by 5 to be t of 0. So t of 1 is 3, divide that by 5, just means that t of 0 is 3 over 5. So if we plug both of the things in that we know, we can say our final equation for this one is t of n equals, let's see here, 3/5 times 5 all to the n power. Perfect. All right, so again, that's a really good problem to know how to do. If you're still struggling with that, please make sure you reach out to your grading teacher and get some help. Perfect. Last one. Last one. I'm going to review some systems of equations because, again, that's a super important skill to be able to take forward from Algebra 1. So we're going to do the last problem of our closure assignment here together as well. So 5.132, when a family with 2 adults and 3 children bought tickets for an amusement park, they paid a total of $56.50. The next family in line with 4 kids and 1 adult paid $49.50. Find the adult and child prices by writing and solving a system of equations. All right, so our first step, we got to assign some variables. So again, we got the price for an adult, the price for the kids, that's what we're trying to find. So I'm going to say that I'm going to let A equal the price per adult, and I'm going to let C equal the price per child. All right, so we have 2 families that they give us where they have the number of adults, number of kids, and the total that they paid. So I think we need to write one equation for each family. So the first family spent $56.50. So I'm going to say $56.50 is equal to, they had 2 adults and 3 kids. So I'm going to say 2A plus 3C is equal to $56.50. Then we just got to do the same thing for the second family. So the second family, they paid $49.50. So we can say $49.50 is equal to, they had 1 adult and they had, let's see here, 4 kids. Perfect. So now we just got to find a method to solve our system right here. So we don't have any variables by themselves, so I don't think equal values method or the substitution method is going to be our friend here. But I think we can potentially cancel out a variable with elimination. So I'm going to say let's cancel our A's. So if we want to cancel our A's, we've got a positive 2A here. We need to make this negative 2. So when we add those 2 things together, then our A's go away. So let's multiply this bottom equation, the entire thing, by negative 2. So we got to take negative 2, distribute it to every single term on the bottom equation. And when we do that, we get negative 99 is equal to minus 2A minus 8C. And again, that green equation on the top still stays exactly the same, but I'm going to write that underneath now. So we got $56.50 is equal to 2 adults plus 3 kids. And now we can add our 2 equations together. So if we add 99, or negative 99 and 56.50, we get negative 42.50 equals, our A's go away, and then we're left with minus 5C. So now if we want to solve for C, because our A's went away, we can divide both sides by negative 5, divide by negative 5, so that tells us that C is equal to $8.50. So we know that per kid, they have to pay $8.50. So now that we know the price per child, we can take that and plug it back into one of our 2 equations. I'm going to plug it into the bottom one. So we can say now that $49.50 is equal to A plus 4 times the price per child, which is $8.50. If we multiply $8.50 by 4, what that turns into is $34. So we have $49.50 is equal to A plus 34. Now we just got to subtract 34 from both sides, subtract 34 from both sides, and we are left with the price per adult, which is $15.50. Awesome. So that is where we are going to stop the video for today. Again, as you're studying for the test, I hope this video helps a little bit. If you still have any questions or concerns as you're working through the closure assignments or just reviewing your notes, reviewing your homework, getting caught up on stuff before we take this test, please let your grading teacher know because we are happy to help, but we can't help you unless you come and ask for it. So that being said, hope you guys have a great rest of your Monday, and we will see you all tomorrow.